The topics of artificial intelligence, machine learning, and neural networks are often plagued with mystery and apprehension. Often thought of as pseudoscience or science fiction by many, or riddled with so many layers of complexity, the concepts are deemed useless in practicality. Many entry-level computer scientists have the premonition that the lines of code required for AI/ML is too burdensome, and organizations see it too complex of a concept for their engineers to adopt.
However, this couldn't be further from the truth.
We see artificial intelligence and machine learning every day and don't bat an eye. In fact, AI/ML, or artificial intelligence machine learning, plays a pivotal role in our life and leisure. Our Pandora playlist is created via machine learning. The strike zone detection on a television broadcast of a baseball game is computer vision, and a recommended path on Google Maps is optimization. All of these components of artificial intelligence. Many software engineers and data scientists use artificial intelligence and machine learning interchangeably, and it is becoming more acceptable to do so in practical applications. However, in theory, machine learning is a component of artificial intelligence. The concept of artificial intelligence was coined in 1955 by a summer research team at Dartmouth College. They defined artificial intelligence to have 7 key structures. The first is simulating higher functions of the brain. They would include the ability to identify key components of the outside environment, or come up with solutions to a particular problem. The second is programming a computer to use a general language. This would be a computer understanding human language, whether it be text or speech, just as one human would communicate with another. Thirdly, AI would include hypothetical neurons in a manner so they can form concepts. This is the basic concept of human thoughts, such as a map of pixels form an image, or a rendering of audio waves form a song. The human brain recognizes this behavior, and AI should be able to emulate that. Fourth is a way to determine and measure problem complexity. We as humans are able to identify whether or not we can easily solve a problem before beginning to solution it. Being able to measure the amount of resources needed to solve a problem before computing is a major component of AI. Self-improvement is the 5th structure of AI. The ability to learn from itself to improve its calculations is the backbone of machine learning. The 6th structure of AI is abstraction, which is the quality of dealing with ideas rather than events. Humans think of concepts as they relate to a topic in no particular order, while in most programming is done in a sequence or some other logical order. And the final structure of AI is randomness and creativity. This is a very difficult component of artificial intelligence and is very difficult to replicate. Even random number generation is done in a logical manner and is not truly random. These 7 structures of artificial intelligence have since evolved to give us the 7 components of AI, which are natural language processing, speech, expert systems, planning, robotics, computer vision, and machine learning. When developers build a program, they learn the syntax of whatever language they are coding in. They have to learn all the operators, keywords, and functions and order them appropriately to comply with the structure of the programming language. This will allow the code to compile and be converted into bytecode, which the computer is then able to understand. While as humans, though we have a proper grammatical structure, we are able to communicate from person to person without the structure and not throw a fatal error. Natural language processing allows a human to interact with a computer using normal human language or text, such as answers being displayed when someone asks a question on Google search engine. IBM has most famously displayed natural language processing by entering Watson as a contestant on Jeopardy!
Watson, who is Franz Liszt?
Speech recognition and natural language processing are often confused for one another. Speech AI is the ability to understand human sounds, or the ability to transmit human sound. It is often coupled with natural language processing, which is the case for smart home assistants, like Amazon's Alexa or Apple's Siri. However, speech is not dependent on natural language processing. Microsoft's Windows speech recognition software comes on board any Windows computer and converts speech to text on the computer. Amazon's Kindle has a voiceover capability in which the device will convert the on-screen text to human voice. Both of these are speech AI technologies. One of the most recent ramp-ups in online media content is the advent of the self-help chatbot. The purpose of it is to provide expert assistance to any consumer on their site. The idea behind it is with the expert systems AI, the consumer will get access to the information more rapidly and at a cheaper cost to the company. Intuit has spearheaded this with their chatbots for TurboTax, and Bank of America has recently introduced Erica, an AI AI expert to assist with banking needs. Chatfuel is one of many sites that creates expert bots to be applied to any website. But Expert Systems is not just limited to bots. The AI technology is any computer system that is reliable and flexible and is able to provide a high level of expertise in decision making and problem solving. Planning, or more completely known as planning, scheduling, and optimization, is a component of AI that focuses on the human aspect of recognizing tasks that need to be completed and the time frame in which to do so. Most common applications of this include workforce management, such as Verizon's Field Service Management software, which automatically schedules technicians based on tasks and appointments entered into the system. However, an aspect of this can be as simple as changing your thermostat settings at a deterministic time. Thus, Ecobee's data rhythm technology for automatically adjusting the thermostat based on human preferences is an excellent example of planning AI. Robotics is probably the most well-known component of AI. It is frequently highlighted by Hollywood in science fiction films and is the cornerstone of many science fairs. With companies like LEGO highlighting the simplicity of robotics, it is now easier than ever to contribute to this field. Robotics has the ability to receive input from the outer environment, sight, sound, feeling, etc. Therefore, it is often coupled with other components of artificial intelligence to create a complete system. Arduino has made a business out of making these sensors and selling them as kits for both personal and commercial use. CAPTCHA is a challenge response system to determine whether a human is actually using a sight and not a robot, and is the best way to explain computer vision. Until recently, it was too difficult for a computer to determine which squares of a traffic image contain portions of a car, or what a word says when it contains different fonts and different shaded backgrounds. However, with the surge in computer vision technology, in conjunction with machine learning, a computer is able to make those determinations that, in the past, only humans were able to identify. But it's not just hackers using this technology. The self-driving car prototyping, with Tesla and Uber leading the way, is leveraging computer vision to determine where stop signs, pedestrians, other vehicles, car lanes, and much more are in relation to the autonomous vehicle. Machine learning is often considered the most complex aspect of artificial intelligence, but it really does not need to be that complicated. In contrast of normal programming, where there are rules and data that produces some result, machine learning programming takes in results and data to determine the rules. The rules can then be applied to different data sets. For example, if someone wants to determine whether a door is opened or closed, a bunch of pictures can be taken of the door with the result of whether it is open or closed, and let the algorithm determine the rules. Under traditional programming, all of the cases of the door, such as the color, height, width, and the characteristics of the surrounding environment, would have to be taken into account. A programmer cannot anticipate all of these circumstances, making machine learning advantageous. Machine learning can actually be very simple. In this example, we see two sets of data, orange and blue. Blue has a low x and y coordinate value, and orange has a high x and y coordinate value. The gray dot is unknown whether it is blue or orange. However, since it can be seen between both clusters, and there are more orange dots than there are blue dots, it can be determined that the gray dot should be orange. This is the k-nearest neighbors algorithm, and is an example of machine learning. Neural networks is a concept of machine learning that appears to be convoluted. While the data and the math behind it may be, the theory behind it is quite simple. Every dot is a data set, and each line a function. There is math that calculates the probability of the next dot being its outcome, and the most likely dot is determined by its solution. Thus, the green dot would be a picture of the door, each blue dot one of its components, the frame, the surrounding area, the doorknob, and the yellow dot would be the result. These are the core components of most machine learning programs. The reason machine learning is often confused with artificial intelligence is because it is frequently accompanied by other components of AI. All of the subcomponents can be used in conjunction with one another to make an even stronger example of artificial intelligence. While artificial intelligence and its subcomponents are very useful to modern technology, I hope you are now convinced that all the topics are not as obscure as they once seemed. As technology matures, these topics will become even more inundated in our daily lives, so it is important now more than ever to familiarize ourselves with them.